Okay, and so what we're doing in this lesson is we're beginning Unit 6, which is solving systems of linear equations or linear systems. And so what a linear system or system of linear equations is two or more linear equations, and this makes up what is known as a linear system. Effectively, what we're trying to do is if our two equations would have two variables, the same two variables, let's say x and y, we'll end up with two equations, each with an x and a y, and we will attempt to find the values of both x and y. And so this is a system of equations. There are several different methods for solving them. What we're going to do in the first two lessons, so today's lesson and the next lesson, is focus on methods, analytical methods or algebraic methods, also known as manually solving the system. And so pen and paper, and then later on in the unit we'll be using the graphing calculators in order to solve them. And so effectively what we need is, in order to be able to do this, are our knowledge of solving linear equations in one variable, and we're just going to extend that to two variables. Okay, and then as pointed out here, the solution of a linear system with two variables ends up being an ordered pair. And so remember, an ordered pair typically is an x value and a y value. And in this case, since we have two equations with an x and a y as an unknown, one x value and one y value is the typical result when we solve a linear system, although there are exceptions. Okay, and so what we're going to do today is focus on using what's known as the substitution method. Detailed here are the steps, and so what I'll do is I'll talk you through those steps as we go through. And so to begin, as an introduction, what I'll do is just walk you through a guided example to show you how it works, and then we have a series of additional examples on the next pages. I'll do one or two with you and then leave you to do a couple to try, and I'll show you how to do those in the second video. Okay, and so this is really meant to give you a step-by-step breakdown of how to solve this. And so we have two completely separate equations. There's no need, but we could number these as equation 1 and equation 2. They are different equations, as you can see, but both of them are linear, and both of them contain one x and one y. Again, remember, we referred to these equations as linear because if we were to graph them, they would produce a line. Okay, and so we have x minus y is equal to 3x plus 2y equals minus 6. We are using the substitution method, and so what the substitution method has us do is to pick one of the equations, pick an equation which has a variable with a coefficient of 1. We can actually also use minus 1. In this case, we have either equation 1 or equation 2. Of course, the coefficients of three of our terms are 1, or in this case minus 1. And we could choose any one of those equations and variables. And so what I did in this example was to select the first equation, and what we have to do after selecting an equation, so you see the equation over here is unchanged. I'm going to select a variable, which in this case it makes sense to select the x, and I'm going to isolate the x. So in this case I add y to both sides, and I get the equation or expression x equals 3 plus y. Okay, and so this has come from equation number 1, and therefore what I do is I substitute this expression into the second equation, the one I did not use to find the x value. And so this is our second equation, x plus 2y equals minus 6. In the place of x, I have substituted in 3 plus y, hence the name of the method, the substitution method. I'm able to substitute 3 plus y because, of course, we've established x is equal to 3 plus y in the previous step. Now, as you'll see from this, we are now left with 3 plus y plus 2y equals minus 6. This is an equation with only one variable, one unknown, and that is y. And using our normal steps for solving equations, we're now able to isolate y and obtain a numerical value. And so y plus 2y gave me my 3y. Move the 3 to the right hand side by subtracting, and so minus 6 minus 3 gave us minus 9. Divided through by the unwanted coefficient, and we obtained the y value of -3. We've now got part of the solution. If this were an ordered pair, we would have, of course, the y value, but we still need the x value, and so what we do is we substitute our answer back into our expression. So of course we know that x is equal to 3 plus y. If we now know that y is -3, we can substitute that in and find a numerical value for x, and this gives us a final solution of x equal to 0, y equal to -3, or 0 -3 if we write it as an ordered pair. Okay, so that gives you a breakdown, a walkthrough of how to solve a system of equations or a linear system using what is known as the substitution method, and this will be our focus for this lesson. Okay, and so what we have now are a couple of examples and a word problem. And so what I'm going to do is solve the first equation with you, and then at that point we'll pause, or we'll stop the video, and I'll have you attempt 1b and example 2, and you'll be able to see solutions of those in the second video. Okay, and so what we have in this system is some of the work's been done for us. We have y equals 3x plus 2, and so step number 1, which is to select an equation and isolate one of the variables, has in fact been taken care of for us, and we can go directly to step 2, which is a substitution step. And so we have x plus 2 times y equals 11, and what we can see, of course, is that y is equal to 3x plus 2, and so in the place of y I'm going to substitute in 3x plus 2. I now have an equation with only x's as the unknown, and now I'll go ahead and find the value of x. So we have x plus 6x plus 4 equal to 11. Rearranging the equation, 7x is equal to 11 minus the 4, which is 7. Dividing through by the unwanted factor, we then have x is equal to 1. This is part of our solution. We now substitute that value back in, and so we have y is equal to 3 times x plus 2. We've established that x is 1, and therefore y is equal to 3 plus 2, and y is equal to 5. And so x is equal to 1, y is equal to 5 as before. If we wish to write that as an ordered pair, the solution which satisfies both sets of equations is 1, 5. Okay, so at this point I'd like you to attempt 1b, which is slightly more complicated, and then go ahead as well and attempt the word problem on the next page. And once you've done that, then go back and watch the second video, which will give solutions to those two examples.